Okay, chapter 2 was logic and reasoning, and it was packed full of vocabulary. The first vocabulary word we learned was a conjecture, and just like in science class, a conjecture is an educated guess. When we make a conjecture in geometry, we do it based on patterns that we observe. So, for example, if you notice that Rick and Bobby have pizza every day for lunch, your conjecture that on Friday would be that they'll also have pizza for lunch. A counterexample is a way that you would prove that conjecture is false. So going back to Rick and Bobby, if you had the conjecture that every day they eat pizza for lunch, a counterexample could be is if you notice that they eat steak for lunch one day. So that's a counterexample that proves that they don't eat pizza every day for lunch. Your conditional statement is the conditions that are true. So, for example, if you speed, then you will get a speeding ticket. Conditional statement is always written as an if-then statement. The if-then can be represented symbolically with an arrow. So if you see the arrow in between two letters, that's read if-then. And we use the first part of our if-then statement, call it P, and the last part following the then, we call it Q. So if we say P arrow Q, it's read as if P, then Q. So looking at this if-then statement here, or this conditional here, if you speed, you speeding would be P, then you will get a ticket. You will get a ticket is our Q. So just writing P and Q like this only shows us that we had a hypothesis, that's the part that follows the if, and we have a conclusion, the part that follows the then. When we put an arrow in between those two, P and Q, it now is read if P, then Q. The converse of our conditional is to reverse the original conditional. And the way I would always remember this is like the shoe, converse shoe, that you can do a backflip in your converse shoes. And what that means is that if your original conditional is if P then Q, we can take the converse of that conditional and write if Q then P. So going back to our speeding ticket, the original conditional if P then Q was if you speed then you'll get a ticket. But if I want to take the converse of this conditional, I would say if you get a ticket, then you sped. So I flipped my P and my Q. That's the converse. The inverse is to keep the conditional as it originally was, except now we're going to negate the hypothesis and we're going to negate the conclusion. The symbol for negate is what's called a tilde. And so what I would do is I would take my original conditional, if P then Q, and I would negate the P and I would negate the Q. So going back to my speeding and then getting a ticket, the inverse of this conditional would be if you don't speed, then you won't get a ticket. So the inverse is to insert a not. The contrapositive is when you negate and flip the original conditional. So the contrapositive is a combination of the converse plus the inverse. So if I ask you to take the contrapositive of my original conditional up here, I would say first flip it, getting a ticket and then speeding, and then negate it. So if you don't get a ticket, then you didn't speed. So if you don't get a ticket, then you didn't speed. Okay, and then finally, when we were doing logical reasoning, we had two things called logic laws that we used in order to decide if statements were valid. The first was the law of detachment. The law of detachment was when you were given your original conditional, and then they offered you some piece of the original hypothesis, P. You can conclude by the law of detachment that Q is true. Okay, so for example, let's just say the speeding ticket example again. If you get a ticket, then you will, if you speed, then you will get a ticket. Okay, that is my original conditional. This will be given to you. So that's your P then Q. And then let's just say that Miss Flip went driving one day and I was speeding. Well, somebody driving and then speeding is referring to our hypothesis, someone that speeds. So based on that example about me speeding, what would you conclude? Well, the conclusion is that Q is true. So Miss Flip is going to get a ticket. Then we had the law of syllogism. The law of syllogism was like the transitive property. You're starting off with your original conditional, if P then Q. They're also going to, in the next set of statements, they're going to introduce Q again, and then they're going to talk about some new thought or idea that we haven't referred to yet. And then your job would be to conclude that if the two Q's are back to back, that P then R is true. So P, then the last statement, R, is true. So for example, let's go back to speeding and getting a ticket. So if someone speeds, then he or she will get a ticket. Someone speeding is my P, he or she getting a ticket is my Q. Okay, let's introduce the Q again and then some new idea, R. So someone's going to get a ticket. That's referring to our Q again. Someone got a ticket. Then he or she will go to court. Well, we haven't talked about going to court yet. That's a whole new idea. We call it R. Well, you notice the pattern, PQ, QR. So the law of syllogism is basically saying, let's cut to the chase. If someone speeds, what's the bottom line? Well, the bottom line is, if you speed, you're going to court. So your conclusion, that's what the three little dots here mean, conclusion. Therefore, if someone speeds, then the bottom line is he or she is going to go to court. And that is true to P then R.